Hello, welcome friends. Me Anila. The topic of my discussion is about buffer. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you how to solve toughest numericals on buffer part 1. So before coming to buffer, I want to give you some explanation about acid. What is acid? Acid is a substance that produces hydrogen ion in aqueous solution. Base is a substance that accepts hydrogen ion in aqueous solution. Strong acid dissociate completely in aqueous solution. Weak acid dissociate partially in aqueous solution. Strong acid example is hydrochloric acid. Weak acid is acetic acid. Strong base dissociate completely in aqueous solution, that is sodium hydroxide. Weak base dissociate partially in aqueous solution, that is ammonia. Now, what is pH? pH and pOH these are scales from 0 to 14. If pH is less than 7, it is acidic. If pH is more than 7, it is basic. If pH is equal to 7, it is neutral, such as pH of water. In the same way, pOH is reciprocal of pH. Now, what is conjugate acid and conjugate base? For example, if we have a weak base, that is ammonia, in aqueous solution it dissociates into ammonium ion and hydroxyl ion. Ammonium ion is the conjugate acid of ammonia. Similarly, acetic acid in aqueous solution dissociate into acetate and hydronium ion. So, acetic acid is weak acid and acetate is conjugate base of weak acid. Now, what is buffer, which is our actual topic? So, for example, buffer is a solution that resists changes in pH. For example, if we have a buffer of acetic acid and sodium acetate, acetic acid is weak acid, sodium acetate is a conjugate base. This is buffer solution. It resists changes in pH. For example, if we add strong acid in this buffer solution, then hydrogen ion reacts with acetate to form acetic acid. So we are adding strong acid and the formation of weak acid occur. So the changes in pH is small. Similarly, if we add strong base to this buffer solution, then hydroxyl ion reacts with acetic acid to form acetate. So we are adding strong base and weak base is formed. So changes, pH change is small. So buffer is a solution that resists changes in pH. In this video, I will tell you how to solve toughest numericals on buffer part 1. Example number 1. A buffer contains 0.4 mole ammonia and 0.5 mole ammonium chloride in 1 liter solution. pKb of ammonia is 4.75. 0.1 mole HCl is added to the solution. Find the new pH. So here is a mixture of buffer, that is ammonia, that is weak base, ammonium chloride, it is a conjugate acid. Because it is in 1 liter solution, so concentration of ammonia is 0.4 molar. Similarly, ammonium chloride is 0.5 molar in 1 liter. So the concentration of ammonium chloride is also 0.5 molar. pKb of ammonia is 4.75. Ka is the dissociation constant of acid. Kb is the dissociation constant of base. And pKb is the negative logarithm of dissociation constant of base, which is called pKb of ammonia is 4.75. zero point 0.1 mole HCl is added to the solution. So we are adding a strong acid in this buffer solution. Now we have to find the new pH, because after addition of HCl, the solution pH is changes slightly. Not find the new pH solution. Now we will write equation ammonia, a weak base, plus we are adding HCl gives us ammonium chloride. Initial concentration is ammonia concentration is 0.4 mole per liter, that is 0.4 molar. Initially hydrochloric acid is not added, so it becomes 0. Initial concentration of ammonium chloride is 0.5 mole per liter, that is 0.5 molar. Now we have added 0.1 molar HCl. So this 0.1 molar HCl reacts with 0.1 molar ammonia to form ammonium chloride. Now final concentration of ammonia is 0.4 minus 0.1 molar. It becomes 0.3 molar. Final concentration of ammonium chloride 0.5 molar plus 0.1 molar gives us 0.6 molar. So the final concentration of this buffer solution is ammonia is 0.3 molar and ammonium chloride is 0.6 molar. Now we will use Henderson-Hasselbalch equation to calculate pOH and then pH. Using Henderson-Hasselbalch equation, there are two equations of Henderson-Hasselbalch. One is pH is equal to pKa plus log salt upon acid. Other is pOH is equal to pKb plus log salt over base concentrations. Because we have weak base and this conjugate acid, so we will use the equation pOH is equal to pKb plus log ammonium chloride, that is salt divided by weak base ammonia. Now we will calculate the pOH of solution. We will write pKb value is given already 4.75 plus log. We will write final concentration of ammonium chloride 0.6 divided by final concentration of ammonia 0.3. 0.6 is divided by 0.3, we get 2. 4.75 plus log 2. You can calculate log 2 from calculator, it becomes 0.301. So 4.75 plus 0.301 is equal to 5.05. So pOH of this solution is calculated to be 5.05. But we have to calculate pH. Now we will use another relation which you have to memorize. We know that pH plus pOH is equal to 14. So pH is equal to 14 minus pOH. pH is equal to 14 minus, we will write pOH 5.05. After solving, pH is calculated to be 8.95. So the new pH of this solution is calculated to be 8.95. In this way, buffer is made. So buffer is made in this way. Friends, if you have any question, you can ask me on comments. I can help you. Thanks. I will describe other part in my next videos. Thanks.